Welcome to Sherlock V1 Conceptual Overview. Sherlock is exploit protection at protocol level, protecting end users from being exploited. There are certain entities interacting with a solution. These are protocols, these are stakers, this is the Sherlock DAO that governs the protocol, but also has a decentralized security team. And when I talk about the solution, I mean the V1, and these are the current contracts. So how does it work in case you're a protocol? So the first step is that the protocol and the DAO need to agree upon a premium. As you can imagine, some protocols are more riskier than others. So the DAO has pricing and security experts, and they agree on a premium with the protocol. The DAO adds and manages the protocol in case there is an agreement, and then the protocol starts paying the premium to the solution. In case of an exploit, there is a payout from the solution to the protocol, so the end users using the protocol are being reimbursed for that exploit. So, protocol pays the premium to the solution. The stakers put their money at risk by providing capital to the solution, and in return they are rewarded for taking that risk because part of the premium is being distributed to the stakers. Part of the premium goes to the decentralized security team, the Watsons, and the task of the Watsons is to keep the protocol safe and to not be exploited at all. So good to know about the premiums, how it works in the contracts. So as said in a couple slides back, premium being paid, and technically it means it's like internal accounting that the debt to the solution is accruing per block. So the premium is like a variable, and like based on the last time it was paid off, it accrues per block. The premium is calculated using the TVL, so the total value locked in the protocol, plus the token price, the token they pay the premium with. And this, the outcome of this calculation is not calculated on chain. It's expected as a parameter in the function. So this calculation is not in scope. The on-chain premium never matches the real premium exactly. So there's no update every block, because the TVL and the token price of course change, always go up and down, are always changing, and it never matches the exact premium, but that's fine. Point 4, accounts are expected to deposit an active balance in name of the protocol. So their debt from the protocol is accruing per block, and there needs to be an active balance to make sure the protocol can pay off that debt. And all accounts can deposit an active balance for that protocol. So good to know about other parts of the code. Payouts are executed by an external address. So there's no on-chain assessment of protocols being exploited. This is done off-chain by the DAO, by the committee. And once there is an agreement that protocol is being exploited, and for a certain amount, the transaction is executed and the payout is being done. Point 2, stakers are subject to a cooldown period for unstaking. So when I stake my funds and I want to get my funds out, I have to wait, for example, for 7 days, and that's the cooldown period. Lock tokens represent tokens staked in the solution. So when I deposit, for example, DAI, that I can only get a DAI out after 7 days. But when I deposit, I get locked DAI, and that locked DAI can be traded freely. And with that locked DAI, I can redeem my stake DAI. So the design goal for this initial version was as follows. Stakers can stake using an array of tokens, and protocols can pay a premium using an array of tokens. And these arrays are different, but I could overlap, but these are just like different arrays also in the solidity. So, as I said before, the premiums are distributed to stakers, and the array of premiums can be large. It can be 10 plus, depending on the growth of the protocol, of the solution. And this causes potential gas issues for stakers, because if there are like 10 premiums being paid in 10 different tokens, then there need to be 10 token transfers to reward the staker, and that's messy. It's a potential gas issue. So that's why we are introducing SureX. SureX is a single token, and this can be redeemed for like the underlying array of tokens at any time. So the staker is always rewarded in SureX, but the underlying tokens of the SureX can change over time. The solution is built using the diamonds, this EIP. And what this means is basically like all logic in the facets folder lives at the same address and shares the same storage. So this can be seen as like a single contract. And auditing the diamond is not in scope, but more info can be seen as this URL. So the structure, to get some confusion out of the way, so we add like multiple tokens, like can be like 10 different tokens from the stakers, 10 different from the premiums, and every token has the same storage layout, and the pointer to the storage is calculated based on the token address. The staker journey is as follows. The staker stakes and sends their funds to the solution. When their funds are staked, they're able to get their money out by activating the cooldown. They are subject to a 7-day cooldown period, and once their cooldown expires, they have like a window of opportunity to actually get their money out. This is probably like a 2-day period, and the user can unstake. If the user fails to unstake in that unstake period, the funds are back to being staked by calling the expiry function. And if the funds are staked again, they have to call the activate cooldown again to start the cycle and to be able to get their money out. Thanks a lot for listening, and if you have any questions about the code or about other things about the solution, please hit me up on Twitter or on Discord. And if you want to know more about Sherlock, visit our docs and follow us on Twitter. Thanks.